of our stay here. Okay, and I believe we have learned one or two things. Okay, we have learned one or two things, and I also had an idea on how to carry out research in MHDs and in general relativity. Okay, so we'll try to see how we can conclude what we have been doing. How we can conclude at one stage what we have been doing. Okay. Then from there, we can come out with something. For we now think of possible ways of expanding it. Okay, so we are trying to see if we can get the field equations. If we can get the field equations, we are good to go. Okay, so with those field equations, we can be able to come out with at least a research article. And then trying to solve those field equations is another problem on its own. If we see hard time, we'll have said, let's just go ahead to solve at least one or two of those field equations. Okay, and then maybe marry in some aspects of fluid dynamics into our field equations. Okay, but so that one will be done later. That one will be done later. So yesterday we were looking at the Riemann-Christoph field tensors. Okay, and I asked you to go and do a second check to be sure that all of them are intact. Okay, so I'm sure you did that. And you took care of the anti-symmetry of that tensor. Okay. You are able to get the curvature scalars. Okay. What about the Einstein tensor? Are you able to get the Einstein tensor? Okay, let me see what you got. Okay. It's heavy. Okay. I hope we have numbered the pages. Yes, okay. So that I don't mix them up. So our okay. So was there any challenge? Was there any challenge? Was there any challenge? I think the only challenge is to be careful. That's the only challenge, to be patient, to be careful, to make sure that you don't make any mistakes. Okay? this rising tensor, we're able to confirm that all the off-diagonal elements are 0. Okay, that, let's say R 0, 1 is 0. Okay, that it will be what is it going to be? It will be R 0, 1 0 0 plus R 1 0 1 1 plus R 2 0 1 2 plus R 3 0 1 3. Okay, is this 0? Is that 1 0? Is this 0? This one is not 0. Zero 1 0 is 0 1 0 0. Oh, and even this one is not 0. This one is not 0. I'm seeing it here now. This one. Where is it? Or is it my eyes? Let me see. Okay, there are 2 zeros there. There are 2 zeros, not 1 0. For the one you have here. And we need to be very sure. 2 0 1 2. Okay. 3013. And going by this, three zero zero two. Okay, going by this, then what we are saying there might be true. But what about this? What about this one? What about that one? Let's check that one too. Zero two zero. I'm seeing one. Okay. 3. Yes. 0 0220. We have that. Okay. Then we have 0202. Okay. And 0303. 011. Okay. Which one? This one? It should be it's 02. Well, it's 0. So all of them are, even the last one is 0. Okay. So what about R12? So the R0120 plus R1121 plus R2122 plus R3123. What about that one? R3123 is 0. R2122. The R0. Okay. Again, all of them are zeros. Okay. Again, all of them are zeros. All of them are zeros. So we don't have any case there. Okay. And then we have R13. R13 will be R0 130 plus R1131 plus R2132 plus R3 133. I want us to be very sure that they are 0. Okay? I want us to be very sure, and I know because of the nature of our metric that is diagonal, that is what is making most of them to be 0. It's simplifying the problem for us. So let's see R0 0 dots 0 1 3 1 1 3 1 is also 0 2 1 3 2 2 1 3 2 is also 0 3 1 3 3 is also 0. So we are sure of that. Then what about R23? We have R2300 plus R1231 plus R2232 plus R3233. So 0230 does not exist. 12312 okay, that 1 2 is missing. And then 232 is also missing. 3233 is also missing. So we are sure. We are sure. Okay? Because once this is 0, the other one will also be 0. Okay, so we have checked 10. Okay? We have checked 10 of them already by doing this. So we are left only with how many? No, there are 16. So we are left only with 6. So which one have we not checked? We have not checked 0, 3. Okay? We have not checked 0, 3. So we have R00030 plus R1031 plus R2032 plus R3033. Okay, this one too will be 0. So we have checked 1, 2, 3, 4, 5, 6 times 2. We have checked 12. So we have only the 4 diagonal elements remaining. We have just R00, R11, R22, and R33. Okay, so we have checked these ones. We are sure that these ones are zeros. Okay, so we are confident we can now continue with the other ones that we got. So we can continue with the other ones that we got. So so your R will only be in terms of them. So our R will be G00, R00 plus G11, R11 plus G22, R22 plus G33, R33. I've eliminated the other ones. Paraventure, one of these was not of the other off diagonal elements. Paraventure, one of them was non-zero. It will not even contribute to this because our G's are all okay. Let's take for instance that we had an R02 that is different from 0. then we will need a G02 R02, which automatically will be 0 because you don't have this. Okay, because you don't have this. So once you get your metric tensor, from there you can begin to guess how many field equations you will get. Your metric tensor has six components. You automatically, you know, you are heading towards 6 field equations. Okay, like most of them in spheroidal, there are 6. So you end up with 6 field equations. But here we'll have four field equations. Okay. So we can substitute our values for this, and that. Okay. So were you able to do the substitution? Let me see it. Oh, you have not given me that one. Okay, curvature scalar. Okay. It looks so beautiful. Okay, it looks so beautiful. Okay. Most of the time, I don't always like to substitute this G. I want to substitute it at the end. Okay, so that it doesn't cost me while on the way. Okay. Okay, it's a good one. It's a good one. So from there, we now have our Einstein tensor. Okay. We now have our Einstein tensor. Okay, and the Einstein tensor again will have 4 components. Is that not? It's going to have 4 components. Okay, so we have our Einstein tensor. Okay, so you can get the 4 components of the Einstein tensor. What are you trying to do here? Okay, I'll try to calculate this first. Okay. This is what I'm looking for. G00, G11, G22. Okay. And finally G33. Okay. Good. So we are done with the left hand side. The only thing now is to substitute those gammas and try to simplify them. Okay. So once you have that, you just take one term after the other, simplify one term. At the end of the day, so many things will marry each other and cancel each other. Okay, like what I said the other day, those components are appearing in the metric tensor. There's no need multiplying them out. You just leave them like that. At the end of the day, you see them canceling out. Okay, like those square brackets, those, you just leave them the way they are and just try to substitute. At the end of the day, you see them canceling out. So we now have all of this. Okay, we now have all of that. So now our next target now is to handle the right hand side. Okay, to handle the right hand side. Now right hand side, is this should be equal to 8 pi g over c to the power 4t alpha beta. Okay. So you are able to get T alpha beta for a perfect fluid. Okay. We got it as T alpha beta is equal to rho 0 plus P0 U alpha U beta minus P0 G alpha beta. Where? In front? Okay, there's minus here. There's minus there. Okay. So we have that. So we have that as our stress tensor for a perfect fluid. Okay? For a perfect fluid, where rho 0 is the proper density, P0 is the proper pressure. Okay? So you can get your T00. T00 will be when this is 0, this is 0, and this is 0. Okay? Remember, this is the 4 velocity. Okay? This is the 4 velocity. The 4 velocity vector. So this is the 4 velocity. Okay? So you have 0, 0. Okay? And then you have 0, 0 here. So in solving your problem, so at this stage we can decide to leave it like that. Okay? So in solving your problem, you can make more assumptions. You can make more assumptions. Okay? Especially with regards to the proper pressure, the proper density, and the velocity vector. Okay, you can decide, since your metric is in polar coordinates, you can decide to have a velocity only in the radial direction. You assume that your star is irradiating matter in all directions radially. Okay, it's like a shooting star. It's just okay. So it's, and then only maybe U1 and U1 will survive. The other U's will go. Okay, so from there you will simplify your equations, and then you can start solving them. Okay, having this. Okay, okay, yeah. Okay, so one expression with the, okay, having c squared. It doesn't change anything much. It doesn't change anything much. Okay, most of the time, at times they will take part of this c and put inside here to help them solve the problem. Okay, part of this c to the power 4 will be incorporated into the stress tensor. So that's what is done at times. So they will take part of this c to the power 4 and incorporate it inside. Because actually these constants that you see here, they are not for nothing. They are there to make the equation dimensionally correct. Okay? Carefully, the dimensions of this have been sorted out. Okay, and to balance these dimensions on the right hand side, you need to bring in these constants. Okay, you need to bring in these constants so that they can balance the dimensions on the left hand side. If they are not there, this equation will not be correct. Okay, this equation will not be correct. Okay, so that is the essence of bringing in some of this. Okay, and as we said earlier, you need to bring in something that is related to gravity. Okay, you need to bring in something that is related to gravity so that you can take care of those of some of those parameters. So in essence, we have been able to arrive at the field equations. Okay, we'll be able to arrive at the field equations. So it's in solving the field equations that you now need to substitute your gammas and substitute all those things and try to simplify them. Okay, and try to simplify them. Because at the end of the day, you discover that your equation has just one unknown. It will be a partial differential equation. Okay, it will be a partial differential equation in R. It's going to be a partial differential equation in R, which can be solved. It will be R and theta, R, theta, and phi. So you can make some other assumptions, and then you try to solve that equation. Okay. And then you will see the way R is behaving with respect to maybe the Hilbert radius and with respect to the radius of the mass. Okay, so you can do that. So once you get your expression, you can decide to also play around with P0 and rho 0 and see what it gives you. If you go into literature to try to see how people solve these field equations, you will discover there are a lot of assumptions that are made. Because you make assumptions to make your problem easier, so that it comes to what you know. Okay? You see, like what Prof was saying yesterday, you will try to simplify your problem to come to a Bessel equation. Because you have a solution to Bessel's equation, the Legendre equation, okay, Laguerre, and so on. So there are so many ways to play around with it so that it reduces to a standard differential equation that you know, whose solution you can invoke. Okay, another way we approach the field equations is to use power series expansion. Okay, you assume your solution to be of a form, maybe of a certain quantity that, okay, n, then maybe there's another one here, f of n from 0 to infinity. Maybe your f of r, maybe phi is of this form. Okay, then you now differentiate it and substitute in your field equation. And then now try to get some coefficients and appreciate how the coefficients behave. So this is another approach of solving it. Okay, another approach that is followed is that you decide to make your metric tensor to be a metric tensor in a space without gravity, and then you add a small perturbation. Okay, you add a small perturbation, okay, so this is another approach. So you express your metric tensor. Remember, everything you have written will reduce back to your metric tensor. So you now express your metric tensor as, this is a metric tensor where there is no gravity. Okay? This is a metric tensor in empty space where there is no gravity. Then you now add some small contribution of gravity to it, which is linearly dependent. So when you add some small contribution of gravity to it, which is linearly dependent, okay, at times most of this is like partial, okay, it's like this. And then you now try to find out this small contribution. This small contribution will now be your unknown in your equation. So it simplifies your equation further. Because you know this, and you can easily get this. So you now try to find this small perturbation that has introduced a gravitational field. So this is another approach that we also use to solve those field equations. So these are some of the approaches that are available that we use. Okay. So at least for us getting to this stage, we have achieved something. Yes. Solution. Mm-hmm. No, it's from the way the equation looks like. There are times you will need to make assumptions before you apply the series equation. There are times you need to apply it before you make the assumptions. Okay? So, at times you just need to keep on trying. You might start with this and get somewhere, you need to make an assumption. You might make an assumption, then you need to get to this. Okay? At the end of the day, you even abandon it if it doesn't work. And then maybe you come and start something like this. Okay? You come and start something like this. Okay? So you'll be doing it. And that is why it's very good to go through literature. Because once you go through literature, you have various alternatives to follow. Okay, you have various alternatives to follow. If this one is not working, you drop it and take another one. If it's not working, you drop it and take another one. Okay? There are problems like this you take more than a year struggling to solve. Okay, it take more than a year struggling to solve. I saw one journal publishing negative results, where, or maybe if you have tried several ways and it's not going, you report it the way it is and publish. Okay, so the journal is interested in that, because just your attempts can give somebody an idea on what to do. Okay, so the journal is encouraging people to publish negative results. When you try and it doesn't go, publish it. So you can give somebody an idea. Maybe there's something you are not getting right, and somebody just looking at the way you are going, he might easily correct it and get a breakthrough. And get a breakthrough with the problem. Okay? So for now, we'll end here and report. Okay, we'll end here and report. So all of this, we'll neatly type it and then put in the flesh. Okay, because this is just full of bones. Okay? It's full of bones. So we need to get to the valley of dry bones and order for the flesh to be added to the bones. Okay, so that it looks friendly. So that's what we are going to do. So we'll type them, but it's not everything we type. It's not everything we type. There are some steps we'll leave out and just give results. Okay? So we'll not type everything. We'll just type major findings. And at the end of the day, we put them together and then try to add in some flesh. Okay? And back our flesh with literature. Okay? Back our flesh with literature. So actually, you have achieved a lot. You have achieved a lot. Just doing this, I can give somebody an MSc. Okay, just getting these three equations. You can go for your MSc thesis. Okay, even my prof, just reviewing a field equation, he can give you, like it's what Isam and others did. They just reviewed solutions. They did not solve any new problem. I've gone through their thesis. They just reviewed a solution, going from first step to the last step, and being able to understand it. You will say you are fit to go. Okay, you are fit to go. Okay, so just getting to this is satisfactory work. So what now you need to do is to try to convince somebody that you have done something. Okay? Try to convince somebody that you have done something. And how do you try to convince somebody? By the way you present it. By the way you present it. You have to present it now in a way that will show somebody that you have done something. And that's where most of us get it wrong. We actually do very good research, but at the end of the day, we cannot convince people that we have done good research. Okay? We cannot convince somebody we have done good research. And then, especially in some of these areas that people don't like to go deep into them. Once they see it, they just throw it away. They just throw it away. They will tell you that your work is not. I remember when I was doing my PhD, when I was trying to publish the first paper, I passed through more than 20 journals. I will send, they will reject. Send, they will reject. At editorial, just at the editorial, not even going to the peer review. Okay, just at the editorial desk, they will turn it back. Okay? And until I kept on struggling until I got it right. So that's what we need to do. And when you see me trying to force you to go and look at what others have done, okay, it's for you to have an idea of how we can report this. How do we report this that people will be convinced that what we have done is worth publishing? Okay, it's worth publishing. Okay, so and if you are able to reduce your equation to a certain level, you can also decide to go numerical. Okay, if you reduce it to a certain level, you can decide to use some numerical methods to see the way those things behave. Maybe you can try to get some astrophysical parameters and fit into that equation, and then try to see how it looks like. So that's what can also be done. That's what can also be done. But at this level, we can be able to report. We can be able to report this. Okay, and we can get it right. So what I want us to do now is for us to appreciate other works in literature. Okay, so I gave you two. So each of you will come and tell us about his own. The guy is smiling. Okay, you tell us, you give us the title of the work you looked at, where the work was published, what the person was trying to do. If it's possible, we have the soft copy. We'll project it and look at it together. Okay? We'll project the soft copy and look at it together, and then make some analysis of it. That's just what I want us to do. Okay? That's what I want us to do. So that from there, we can be able to appreciate how we can back what we have done. Okay? You are not able to do that? This is why you are conspiring. Okay? This is why you are conspiring. Okay, so we can give you some time now to do that. We can give you some time, an hour or two, to do that. We'll be doing it together. What I want is for you to identify just 2 papers you are working on. And then you will lead us here. I will lead from behind. Okay? You will lead us here. You will tell us the paper. Possibly read out the abstract. We appreciate the abstract. Then from there, we'll go into the paper and see what the person has done. It's very, very important. Even in any area you are working on, it's very important to do that. Okay, it's very important to do that. It's very important to do that. If you have seen work in this area, the works are very, very similar. They are very, very similar. And when I was to do my PhD, I had a gang that did not want my supervisor to succeed. Okay? So they went and downloaded so many of those works. They downloaded, somebody was sitting with a file of more than 100 pages. Okay, just, so once they see it's similar, they think I'm doing the same thing. But just an R makes a difference. Just a T makes a difference. So once they saw my heading, they saw some of the things in literature very similar to what I have done. So they went and downloaded those things, and they came to stop the work. So fortunately for me, I had read through most of them. So immediately you point it out, I will tell you what that person did and how my own is different from what that person did. Once you point it out, you say, do you know so, what is, how is your own different from that? I will tell you. Because I had taken time to do that. Okay, I had taken time to do that. So once you do that, you have little or no problems. You know, at times when you go for external defense, the first question you ask a student is, what is your contribution to knowledge? That's, if you look at when I'm going for external defense, the first thing I do is I first of all go through the keywords in your title. Okay? The keywords in your title, you explain each of the keywords in your title to me. Then secondly, you now tell me your contribution to knowledge. And most people don't get it right. They will beat around the bush. They will not tell you what they have done. Most of the time, they will be telling you the economic importance of what they are doing, and so on. But the specific research contribution, they will not be able to point out. And when you see that, you know that there is a lack of literature review. There is a lack of literature review, especially empirical review. If you have not carried out your empirical review, you can carry out your theoretical review very well. You can carry out your conceptual review very well, but your empirical review is pending. Okay? And that is why for my MSc students, you must have at least 50. For PhD, it should be more than 100. Empirical review. Okay, you must review at least 50 articles. Okay? At least 50 articles. And when you are reviewing, at the end of each review, at the end of each chapter, you tell me how it's different from your own. At the end of each chapter, you tell me how it's different from your own. At the end of each chapter, you tell me how it's different from your own. So that will make me to know that at least you know what you are doing. Okay? Because if you don't carry out an empirical review very well, you will not be able to identify the research gap. Because each research has a research gap you want to fill. There must be a research gap you want to fill. And if you don't identify that research gap, you are just doing it for doing sake. You are just doing it for doing sake. You don't even know what you are doing. So literature review is very, very important. It's very, very important. Okay? And actually with literature review, you can defend your work without even knowing what you are doing. This sounds funny. This sounds funny. Because you have enough facts with you. You have enough facts with you. You can even defend your work without knowing what you are doing. Okay, you can defend your work without knowing what you are doing. If you have the literature upstairs, you have the literature upstairs. So it's always good to do that. So maybe you can relax a bit. If you have not done that, then you need to do it now. Because I ask you to look for them together and then share among yourselves, so that you don't end up, one person should not end up repeating what the other person is doing. So within 30 minutes, you can be able to share them, and then within an hour or an hour 30 minutes, you should be able to glance through it. I don't expect you to know what is there. I just expect you to glance through it. Then all of us as a class will now appreciate what is on each paper. That's what I want us to do. Are we okay? Yes. Yes.
Change of study area or a new study area serve as a research gap.
It can. It can. It can. It can serve as a research gap. Why will it serve as a research gap? You have seen people have done other works in other places, and no similar work has been done in that place. So you are trying to fill that gap. So it's a research gap because you are doing it in, even if it's the same study area, you can validate or you can see what has changed over the years. Maybe somebody did it 10 years ago. You now want to see what has changed, what the current state of that place. If somebody does work 1 year and you are coming back after 1 year, you don't expect to get the same results. You don't expect to get the same results. That's why at times when you are doing some work, even there are some models you put in they use them mostly in climate change. They use them mostly in climate change. You can be able to see, that's to go backwards in time. For instance, like this center, you can be able to see the way this center was 20 years back. Maybe you see a river that was flowing here, and today that river is no longer there. Okay, so many things will change over time, vegetation and so on. So changing a study area is a research gap. Okay, changing a method in that same study area is also filling in a research gap. So it's done that way. Okay, any other issue? It's okay, so we can break for some time. And then when we resume, we just appreciate some of those works. Once we appreciate some of those works, we are fit enough to have an introduction to our work. We are fit enough to have a methodology to our work. We are fit enough to have a discussion to our work. Then we can marry all of them together and see what we get. Okay? Because we'll not just go ahead getting results. We also, since this is a research-oriented course, we also need to appreciate how to report research. How do you report research to convince the research community that what you are doing is correct? At times, I'm an editor-in-chief to a journal. At times when I see what some people submit, I just begin to wonder whether this person has read through even one paper. You will see somebody who do his MSc work and just take it like that. 40 pages, 50 pages, and send to you as a paper to publish. Once you have collected your 5,000 processing fee, we reject it. Okay. We'll just reject it at that stage. Okay? So once I see that, I know that you don't even have an idea of how a paper is written. You just take your thesis the way you wrote it and just send to a journal for publication. So that shows that the person has not read even one paper. Or at a point, maybe somebody wrote the thesis for that person. Okay, because if you actually read it, you will have read through some related works, and then you know how to. And then even before submitting a paper to a journal, you must have gone through the guide, the journal guide. What does the journal guide say? How should your paper structure look like? They will just take it like that and dump it with you. Okay? So once we see that 5,000 is gone. And then the second thing we also check is plagiarism. Okay, we check plagiarism. We use Turnitin to check plagiarism. Once the similarity is more than 20%, if it's between 20 and 40%, we send it for you to reduce. Once it's above 40%, your paper is rejected. Okay? So, even looking at somebody's work and trying to get an idea from it, you don't just go and copy. You should be able to put it in your own words. You should be able to phrase it differently. Okay? You don't just go to somebody's paper and just copy things from there. At times you see somebody who just copy a methodology, word verbatim. Copy an introduction. So we'll copy a whole paragraph and dump it. At times you see up to 80-90% similarity. Similarity, and the person is claiming to have done genuine work. 80%, 90% similarity. That is it. That is it. That is it. And if you want to take somebody's sentences, maybe 2 or 3, that you have looked at it and there is no way for you to, you put it in quotes. If there's something you have seen and it's difficult for you to paraphrase, or maybe you like it the way it is and it's long, just put it in quotes. The software will pass through it without giving any problem. Okay. So that is very, very necessary. It's very, very necessary. Okay. So you need to also be able to scale through similarity test. There are some journals they don't take more than 10%. Some high impact journals, they don't take more than 10%. Okay, and one good thing with us, especially in theoretical physics, is that with all these equations, it's difficult for you to get a high similarity index. Your similarity index is only contributed from your introduction and your discussion, which you can easily handle. Okay, but when you go to some people in the life sciences, okay, when you want to determine maybe hemoglobin in blood, the procedure is the same, always the same. Okay, at times it's they struggle to reduce similarity. They struggle a lot to reduce similarity because the procedure remains the same. Like most of you especially maybe like the procedure for VES is the same. 2D is the same, 3D is the same. So you need to be very careful to play around so that you don't end up falling into plagiarism. Okay, so most of those things. And I noticed the way you report research in geophysics is different from the way other people report. Mostly in geophysics, the study area comes in the introduction. The study area comes in the introduction. But for most other researches, the study area comes in the methodology. It comes in the methodology. It's okay, so I think we can end there for today. And then another thing too is the choice of journal. There are so many predatory journals. So many predatory journals. There are so many predatory journals. Journals that are just out for money. Okay? So many of them. So you need to do your research very well before you submit a paper to any journal. Look at the editorial board. Look at where the journal is domiciled. Look at the guide to authors, and so on. There are journals who submit a paper in the morning before afternoon. It's accepted. It's accepted. There's one of my PhD students, he sent his acceptance letter because I stopped him from doing his internal defense. He published just one paper, so he needs to publish the second. So 2 days ago, he sent me an acceptance letter from one journal. Just by going through that acceptance letter, I knew that this journal is predatory. Just from the acceptance letter, the type of language they are using, and so on. I didn't see any reviewer comments. Okay? A standard journal should have at least 2 people to review your work. After the editorial assessment, after it is assessed at the editorial stage, and then see that your paper is fit for that journal. Because at the editorial stage, what you do first of all is to check the scope. To check whether the paper is within the scope of the journal. Okay, because each journal has its own scope. Each journal has its own scope. Okay, you check whether that paper submitted is within the scope. Then secondly, you check the similarity. If it's within the scope, then you pass it to for similarity test. If it scans through similarity, then you now send it to reviewers, at least 2. So for somebody to give you an acceptance letter with no reviewer comments and with an account to pay $500, you just know that this one is just out for money. Mm-hmm. You pay $500. Okay. Actually, we have papers that were published for more than $5,000. Yes. Mm-hmm. Actually, it's a collaborative research. We don't have the money here, but they have the money over there. So we did the work in collaboration with them. So they use their funds there and publish it. If it's for me to publish that type of paper, I better take that and go to my village and become a traditional ruler. Okay, so that is that. So you need to check all of those things. Okay. So actually publishing is another thing. You go check the journal very well. Be sure that journal is not predatory. Okay, that journal is not predatory. Okay. There are some journals that are based in Nigeria here, but the address is really US. Okay. The address is really US. Phone number, email address, everything is US. They have somebody there who is collaborating with them. You pay money as if you are paying to the US, but the money will end up here. Okay, there are so many of them like that. Yes, sir. Yes. Most of them don't have. Most of them don't have. Most of the predatory journals, you only see their website. You don't see, they don't have DOIs. But some have. But there are very few that have DOIs. Some have, but, and that should be a first indicator. If you see an online journal and it doesn't have DOI, okay, you need to check further. You need to check further. You need to check further. Because actually, there are institutions that buy DOIs. Like this center now can go and buy DOI. You can buy DOI, and everything that is done in this center will carry the DOI numbers. Okay? No, yeah, mostly those ones they are not predatory. Okay, they are not. That's the starting point, especially in our local journals. You look at institution-based journals and association-based journals. Yeah, they are better. They are better. The institution-based journals, the association-based journals, they are far better than all those journals. Okay. So what we are saying is that it's not only doing research, it's also publishing the research. Okay. Actually, before we have indices with red researchers. There are indices that are used to read researchers. You have citations, you have H index. Okay? You have citations and you have H index. They are used to read researchers. If you go to Google Scholar, okay? You go to Google. I hope most of you are in ResearchGate. Who is not in ResearchGate? Okay, are you in ResearchGate? Okay, you are not in ResearchGate. Okay, maybe when we publish our first paper from here, I will now give you an invitation to join ResearchGate. Okay? I will now give you an invitation. Because once you have an article published with somebody who is a member of ResearchGate, the person can easily invite you to join ResearchGate. Or you use an institution email address to join. That one is a bit cumbersome. So you can use an institution email address to join ResearchGate. Okay, it's very important to be part of ResearchGate. But there are so many facilities you get while you are in ResearchGate. You can even communicate with other researchers. Maybe you are working on a problem and that problem is giving you difficulties. And then you see a researcher in ResearchGate who is working on a similar problem. You can send him a message. And then you can send him a message. I know so many students who have asked me for my papers. Okay, or who have been working on my work and they got stocked up. And then they send a message on ResearchGate and I've responded to them. So if you are not on ResearchGate, please you try and be part of ResearchGate. And you use it to grow. Okay, use it to grow. Okay, and then you also need what we call what is it again? How do you call this personal this identifier number for each researcher? ORCID, yes. Okay, you also need it. Okay, so if you don't have it, try and get it. Okay, if you don't have this, try and get it. That you apply for it, they'll give you. Okay, once you Google on this, you will see the procedure. You go in and give in your about data and give in everything about you. Then they will now give you a number that is unique to you. Okay. Okay, and it's unique to you. So you also try to get that. Okay. Yes. That's what I said. That's what I said. That's what I said. So you have to do that. You have to do that. And then what I even did when I joined ResearchGate is that there are some papers I published in some journals that are not online. I took time and scanned all of them and put them in my ResearchGate account. So people are getting access to those works. People can read those works, although they are not online journals, but they can read them. They can get, and they are citing the works from there. Okay, so some of these tools are very important. You activate them and try to use them as much as possible. Okay, at times now, even when you apply for a grant or you apply for a scholarship, okay, the first thing they will do is they will just try to see your name online. They will just Google your name and whatever. Okay, so even if you don't have a publication, but at least have an online profile where somebody can see you as a researcher. That is it. That is it. So that people can follow you. People can follow you from there. Okay. So if you are not on ResearchGate, we'll try so that all of us should be on ResearchGate. Okay, all of us will be on ResearchGate. Okay. It's okay, so we can stop there for now. Now, come and release me.